Here is the gamma ray detector, and this is the housing, aluminium housing encased with some PVC tape, and here is the construction, and here is the BPW34 pin diode, and we have two BC548 transistors biased for a trans impedance amplifier, and here is LM339, I guess. It's a quad op amp, and I'm using only one op amp to amplify the pulses to trigger this piezo element, piezo buzzer. And for the audio, that you can see a shielded cable connection that I have also terminated out, and for the supply I'm using a 9-volt battery, and here is the rest of the 3.5mm jack, and I am going to use that output from the device towards this cheap ADC, and this will get the pulse, and I am going to feed that into a smartphone or a computer to get the pulse. And so let me show you what we have done for this BPW34 pin diode detector. There you can see a particular contraption. There the detection chamber that we have built actually out of tin can, and there is the detector actually poking through, and this whole container is being sealed when the sample is inside the chamber. And you can see for ticks we have used a piezo element in a foam padding so that ticks can be heard louder. So this is the ticks threshold potentiometer. I will show you the schematic. It's a elector article that we have taken and copied from, and this whole chamber actually sealed, and we are using a cheap ADC connected through USB to computer for mic input. We are using the input from there, and this is the connection. We have minded as much as shielding throughout the whole setup. So let me show you the design and interface. So there you can see elector article, and we have used same circuit but with minor changes. There you can see those transistors we have used BC548 instead of BC549, and some values are actually changed according to our circuit, but you can follow this circuit, and that is the detection that you can directly connect to the audio input of your device. And for the ticks counter, you go down and you can see LM311. It's a comparator, and you can use that as your ticks. So in our design we have used a different op amp, you can see on the circuit. So for the sampling we are actually using application that one of YouTube channel that I have followed, that is the pin diode detection. The UI user interface is kind of like this. There is a threshold that you can see. The threshold you have to adjust it on your pace, how sensitive your detector. And what this will do is this will put a limit to whatever you are recording. It will show you on the window the number of events, and you have to play with the threshold value because there are lots of electrical noise that can interfere with your result. So in my case, in my current setup, I have used this value. It's quite this kind of location. And we what we do is we will, and there is also a channel that shows the accuracy of the channel. If you use higher channel accuracy, this the channel, the energy level that it records, this will increase in resolution. And for higher you can have more higher, but I don't know, in my case I cannot get these values on my site. But instead of getting different peaks on different energy level, I get number of counts in higher order. I don't have currently much high radioactive source, but I do have some thorium gas lantern that I have purchased from old high pressure gas lanterns, and this sample do contain thorium dioxide. So this is quite not normal, but a bit high than background radiation. I have couple of gas mantles that I have located in a tin can, so that can be detected. The number of counts can be increased, but I have not noticed any spikes in other energy level because my source is not that kind of spicy. So instead I have noticed so I will show you the result. So what you have to do is you have to start record, and in your preferred accuracy level, and you have to run it for like half an hour or 1 hour or so to accumulate enough data so that you can look it up and compare with the background. So in the picture that is currently you can see, this picture represents saved value, and this one is the background that I have recorded with no sample in the chamber, and we have recorded this. So this includes the local noise as well as the number of counts. So this parameter will show, this axis will show number of counts, and down in this axis you can get the energy level. So in this case you can see it has started around 85, 84. These are all numbers that you have to calibrate through your process. This will just show the actual value. There is no calibration, just numbers you have to add to your accordance. And there you can see number of counts that it has been detected in 98, kind of the maximum scale that it goes. But this is the without source thing data, and this is the with source data, and that you can see number of counts is quite high, 175. These are all those two samples are run around the same time, so it's around 39 or 40 minutes of data accumulation. And you can see some peaks here, and also increased in number of counts that you can see. If I compare this side to side, you will notice this is our sample. This is the sample that first let me do side by side comparison so that you can see, and this is also put it down to the same scale, and you can see for this sample, let me show you, kind of the same, but this sample, if I rotate my camera, you can see two samples are compared. Here we can see couple of peaks right there, and there is single peak, so that is also an indication of different energy level. There you can see 114 and there is no peak at 114, so that is also a representation of having a different material inside. So this can due to noise, but you can't deny the number of counts that it has. It has 175 and this one is only 98 or something, there you can see, so that you can get a rough idea your source material is spicy or not. Although thorium oxide is primary alpha and beta, low energy beta emitter, some amount of gamma can be detected, but despite having a low sensitivity of the photodiode, the pin detector, the external mask of the detector is enough to block some of the high energy alpha and beta that you can see, not thick enough, so not thin enough, so you might have to use quite hot sources to get proper spectroscopy, but you can get a number of counts in increment, so that you can get a rough idea your material is radioactive or not. So that is how the detection actually works, and the application I will link it to the description from the YouTube channel that I have taken the reference from, and you can do your own pin diode detection